We Magesh, Kirtavasan, and Deepak from the Department of Computer Science Engineering at Veltech Multitech, Dr. Rangarajan, Dr. Sakunthala Engineering College, present our project on credit card fraud detection using machine learning. With the rapid increase in digital transactions, credit card fraud has become a major concern in the financial sector. Traditional fraud detection methods often fail to keep up with evolving fraudulent techniques. Our project leverages machine learning algorithms to analyze transaction patterns, detect anomalies, and predict fraudulent activities in real time. By using a data set from Kaggle, we train models to classify transactions as genuine or fraudulent based on multiple features. Our approach enhances security, reduces financial losses, and improves trust in digital transactions. Through this project, we aim to contribute to the advancement of fraud prevention technologies using artificial intelligence. Problem statement: the increasing prevalence of credit card fraud in the digital era necessitates the development of robust and efficient fraud detection systems. This project aims to develop a machine learning model to detect credit card fraud. The model will be trained on a dataset of historical credit card transactions and evaluated on a holdout dataset of unseen transactions. Abstract: credit card fraud is a critical challenge in the digital financial ecosystem, where the increasing volume of transactions creates greater opportunities for fraudulent activities. This project focuses on the development of a fraud detection system, leveraging machine learning algorithms to identify suspicious transactions in real time. By analyzing historical transaction data, the system learns patterns of legitimate and fraudulent behavior, enabling it to flag anomalous activities for further investigation. The proposed solution employs a hybrid approach, combining supervised learning techniques such as random forest and gradient boosting with anomaly detection algorithms like isolation forest and autoencoders. Introduction: credit card fraud is a significant concern in the modern financial landscape, where the rapid growth of online transactions and digital payments has increased opportunities for fraudulent activities. Fraudulent transactions not only lead to financial losses for individuals and businesses, but also damage the trust and integrity of financial systems. With millions of transactions occurring daily, manual monitoring is impractical, necessitating the use of advanced automated techniques to detect and prevent fraud effectively. Fraud detection systems aim to identify unusual or unauthorized transactions that deviate from normal behavior. Existing system: static rules. Fixed rules cannot adapt to evolving fraud patterns, making the system outdated as fraud tactics change. Inability to handle large-scale data. With the growing volume of transactions, traditional methods struggle to process and analyze data in real time. Limited insights. Rule-based systems often overlook complex relationships between transaction attributes, limiting their accuracy. Proposed system: Phase 1. Logistic regression. This model scored 97.2% in accuracy, 97% sensitivity, and 2.8% error rate. Reduced false positives. By combining multiple algorithms and fine-tuning thresholds, the system minimizes false alarms, improving user trust and reducing operational overhead. Phase 2. Random forest. It's a tree-based algorithm that is faster than linear regression for making decisions and more robust to noise. Firewall and IDS/IPS employ robust firewall and intrusion detection like prevention systems to safeguard data. Biometrics uses unique physical or behavioral traits, like fingerprints, facial features, or voice patterns, for identity verification, offering high security and ease of use. Two-step verification, 2SV, adds an additional authentication layer, such as one-time passwords, OTPS, authenticator apps, or hardware tokens, protecting against password theft and phishing. System architecture: 1. Collecting credit card datasets. The first step involves gathering real-world credit card transaction data, typically from sources like Kaggle or financial institutions. This data set contains transaction details including fraudulent and non-fraudulent records. 2. Pre-processing missing values. Many datasets have missing or inconsistent values, which can affect model performance. Data preprocessing involves handling missing values by either removing them or imputing them with suitable values, e.g., mean, median. Apply oversampling techniques. Since fraudulent transactions are rare compared to legitimate ones, the dataset is often highly imbalanced. Oversampling methods like SMOTE, synthetic minority oversampling technique, are applied to generate synthetic fraud samples, ensuring better model learning. 4. Normalization. Data normalization scales all feature values to a uniform range, improving model efficiency. Common techniques include min-max scaling and standardization to ensure that no single feature dominates the learning process. 5. Feature selection. Not all data attributes contribute significantly to fraud detection. Feature selection techniques like principal component analysis, PCA, or correlation analysis are used to choose the most relevant features, reducing computational complexity. 6. Machine learning-based classifiers. Various machine learning models such as logistic regression, decision trees, random forest, and neural networks are trained to classify transactions as fraud or non-fraud. The model is fine-tuned using hyperparameter optimization for better accuracy. 7. Validation with performance measures. The trained model is tested using metrics like accuracy, precision, recall, F1 score, and ROCAUC to evaluate its effectiveness. A well-performing model should minimize false positives and false negatives while maximizing fraud detection. This is our home page, and this will be our login page. We can sign in by user email and password. If there is a new user, then we just sign up. This is our admin login page. Here we can access admin details, and this is our admin page where we can add the details of customers. This is our fraud detection page. We should enter the asked details. If the transaction is legit, then it will show legitimate transaction. If not, it shows as fraudulent transaction detected and will ask for user email for OTP verification. In this last page, if it is verified, then it will allow for transaction to be done.